A very good morning to you all. Myself, N.S. Trinity, working as an assistant professor in the Department of Forest Ecology and Climate Science in Forest College and Research Institute. So today our topic is about image resolution. So to know more about what is image resolution, let's start our class. So what is image? So to know more about image resolution, first we have to understand what is an image. So image is a two-dimensional representation of objects which we observe in the real scene or in which you are trying to observe it. So the remote sensing represents the parts of the Earth's surface which are seen from the space. So the images can be of two types. One is an analog, the other one is a digital. Now, if analog image is nothing but whichever the images that you are able to take from a aerial photographs, nothing but using ground-based platforms or using the aircrafts, whatever the images that are available, those are called as the analog images. Whereas the satellite images are those which are considered to be called as the digital images. So the images that are captured from the electronic sensors are considered to be called as the digital images. So what consists this digital images? The digital image consists of a group of pixels which are arranged in a two-dimensional way, and they have two important characteristics, or you can say they consist of two things in them. One is the intensity value, the other one is a location address. So intensity value is nothing but the energy radiations which the sensor is able to capture, that intensity value, and is represented as a digital number. Coming to the location address, it is nothing but the row and the column number, basically the longitude and the latitude, which form the coordinates or nothing but the location address. So this is which I was talking in the previous class. You can just refer to it again. Coming to the image resolutions, the fundamental parameters that describe the quality and characteristics of spatial data include the temporal resolution, the spatial resolution, the radiometric resolution, and the spectral resolution. So today we'll learn about these four kinds of resolution. First, we'll talk about spatial resolution. The spatial resolution is nothing but it is the area that the Earth's surface is covered in 1 pixel of an image. So whatever the area that is covered in 1 pixel is considered to be called as a spatial resolution. So in this, if a satellite image is about 4 meters resolution, it means that it is 2 meters by 2 meters Earth's resolution, or you can say it is 2 meters by 2 meters of the area on the Earth's surface. So below are the images of 3 different kinds of spatial resolution. The first image is of 2 meters resolution, then you have 14 meters resolution, and then you have 30 meters resolution. So the 2 meters resolution is nothing but 1 meter by 1 meter. This is 7 meters by 7 meters, and whereas the last picture is that of the 15 by 15 meters resolution. One more example you can talk about the spatial resolution is, imagine you want to see a picture which is having the letter R. So as the resolution keeps decreasing, so is the pixel's clarity. So in the first image you are able to see, in the last image you are able to clearly see the letter, but as the spatial resolution is decreasing, the image is getting pixelated, and hence the clarity of the image is not that much as compared to the high spatial resolution. The next is temporal resolution. Now, what do you mean by temporal resolution? It is nothing but the time taken by the satellite to come back to the same place or the same location which it has passed. So that is something called as the temporal resolution. So each satellite has its own temporal resolution. For example, if you take IRS, Indian Remote Sensing Satellites, which have 24 days, the SPOT series has 26 days, and the IKNOS has 2.9 days. Next, there are 3 different kinds of temporal resolution. The first is called as a high, the second is medium, the third is as the low. Whichever satellite which takes less than 24 hours to 3 days, it is called as a high temporal resolution. Which is between 4 to 16 is called as a medium, and which is greater than 16 days is called as a low temporal resolution. The third type is called as a radiometric resolution. So what do you mean by radiometric resolution is, if you remember in the first slide, I talked about the pixel which consists of the intensity value. So this intensity value is nothing but having bits in it. So the bits are nothing but the binary data, which is 0 and 1. So this binary data is recorded by the sensor. So this recorded information is what is meant by the radiometric resolution. For example, if you take EVHHR sensor, it is able to have 10 bits of data. So this can be considered as a radiometric resolution as 2 to the power of n. N represents the number of bits. So for the AVHHR sensor, the radiometric resolution is considered to be 1024 bits per pixel. So for the same Landsat, you will have 2 to the power of 8 bits per pixel. So if you consider the below example, in 1 bit you will be having 2 bands, which is black and white. In the 4 bits you will be having 16 shades, 16 gray shades are visible. In 8 bit you will be having 256 shades. I can clearly explain this with the next slide. So if you see the radiometric resolution in this image, you can clearly observe that in the last image, it is having 1 bit, so there are only 2 gray shades. In the 2 bit, you have 4 gray shades. In the 4 bit, you have 16 gray shades, whereas in the 8 bit, you have 256 gray shades that are easily able to be differentiated. The next third type is the spectral resolution. Spectral resolution is nothing but the wavelength in which the sensor is able to record the information. So every sensor will not be able to record all the visible or all the electromagnetic spectrum. It will be able to record in few, or you can say in certain wavelength. So that wavelength which the sensor is able to record is called as a spectral resolution. For example, if you take a band 1 of the Landsat TM sensor, it records the energy between 0.5 and 0.52 mm of visible part only. So this is one more example. So if you just take, there are 3 different kinds of spectral resolution. The first one is called as a high, the second is medium, and the third is called as a low. So high spectral resolution is having 220 bands, the medium is having 3 to 15 bands, and the low is having 3 bands. So if you have a bands of only 2, then it forms a panchromatic image. If it is having more than 10 bands, it is called as a multispectral image, and more than 100 bands, it is called as hyperspectral image. And the fourth kind is called as the 1000 bands image, that is called as the ultraspectral resolution. So this is one more example. In this you are having only one kind of band, that's why you are able to see black and white, whereas if you have more number of bands, the picture will have different color shades that are visible to the eye. So this is a comparison table of few of the satellites, important satellites, where you have the GOES, that is nothing but the geostationary Earth orbiting satellite, which is having a spatial resolution of 1 kilometer. The spectral is 1 in the visible band. Then the temporal is 15 minutes. The Landsat is having 30 meters, excellent spatial resolution. The spectral is having 6 bands, and the temporal is 2 weeks. Coming to the Landsat MMS, it is 75 meters, 4 bands, and 2 weeks is the temporal resolution. Then you have the MODIS, which is presently being used in fire detection. So it is having 1 kilometer, 500 meters, and 250 meters. The spectral is 36 bands, and the temporal is 1 day. So these are general comparisons with the satellite. So I hope you have understood what are the 4 kinds of resolution. So to have a recap or conclude what we have learned so far, first we have understood what is image, what does the image consist of. Then we understood what are the 4 different types of image resolution when we talk about the spatial, temporal, spectral, and radiometric resolutions. The spatial resolution is nothing but the area that the pixel contains, that is called as the spatial resolution. Then you have the temporal, the time that the satellite takes to revisit the same location or the point is called as the temporal resolution. The radiometric resolution refers to the intensity that is captured by the sensor. And the 4th type, that is the spectral resolution, the sensor which is able to detect a particular kind of wavelength is called as the spectral resolution. So I hope you have understood today's class, and if you have any doubts, any queries, you can kindly post in the comment box. Thank you.